Everybody, I'm Steve. Thanks for coming. I do not have slides because it's funny, we like all talk trash on PowerPoint slides and how we hate them in meetings and stuff, and then every conference talk is a bunch of slides with text on it. So I also been joking, I just moved to Brooklyn, and so I need to practice my hipsterism, so I have a Moleskine with some handwritten notes, and I will be presenting from that today instead. So. Plus I use Linux and my computer doesn't work on projectors ever, basically. So, that's how that happens. So this talk is called Applications, Libraries, and Languages. And I'll say a little bit about who I am in a second and why I can talk about this topic. But basically, this is a way of thinking about different kinds of programming projects and how working on them is different across things and how your interests may make you want to work on one or the other, et cetera. So that's sort of the general concept. If that doesn't sound interesting to you, I will not be offended if you do what that guy did and just leave. Okay, so if you don't know who I am, my name's Steve. Hi, again. I have been doing a lot of programming over the last little while. I started off as a little kid, but I hate talking about that part because I don't like that myth of the genius child programmer or whatever. So I'll say that I've been doing a lot of work in Ruby the last couple years. So if you've been a Rubyist, you may have seen something or do something that I have worked on. I originally taught people Ruby for a very long time. So I went from dropping out of college and doing a startup to teaching people full-time for years, and then found myself maintaining a large number of Ruby gems and also working on Rails itself. So that's sort of the library phase. And now I'm on contract with Mozilla to work on their Rust programming language full-time, writing documentation and working on that. One of the things I've been thinking a lot about lately and what sort of spawned the idea for this talk is that I think it's exciting that we're in a discipline that is so young. Like, Ruby's garbage collector was originally described in the Lisp paper in 1958, the strategy that it uses, right? And that feels super old in computer years, but in terms of the industries that we make analogies to or we talk about, we talk about ourselves as engineers, right? And engineers build bridges, and humans have been building bridges for a lot longer than 50 or 60 years, right? So I think that we as a discipline don't even know how to talk about programming and talk about the different kinds of programming and talk about the way that we do programming, and it's also new and shiny and young, and we're all kind of just figuring it out to a certain degree. Not that we don't know anything about it, but I'm interested to see what happens when we've been programming computers for hundreds of years or thousands of years, right? And then I'll change things. So when I've been trying to think about ways to think about programming, this sort of particular axis of these three kinds of projects is something I sort of settled on when thinking about my experiences so far in my career as a programmer. I don't think that these three kinds of projects encompass every kind of project. That would be kind of silly. So this is not a complete ontology of projects. This is just three of them. I also don't think that there's a progression involved here, but I'm going to present it as a progression because that's how I experienced it during my particular life. But I don't want to imply that building applications is lesser than building languages, or is lesser than building libraries, or you need to be smarter to work on a programming language than to work on an application, because I think that that's stupid. So there will sort of be a progression, but that's only because we perceive time in a linear fashion. Sorry. Can't fix that. Okay, so application development. When I actually started using Ruby on Rails, it's because I dropped out of college to do a startup. I dropped out my last semester. What a great, uses of all that money. And I was the sole developer with, a business guy building this entire product. And it was my first Rails app. And that was back in the Rails 2 days, and it was super wonderful, but also really awkward because when you're a sole developer building an application, you have nobody to feed things off of. I actually still have that app in a zip file somewhere, and I'm going to give it about another 6 months. I think maybe early next year I'm going to bust it out again and cry at how bad I was at Ruby and Rails, and think about writing some blog posts about then and now and stuff like that. But while not every application is only built by one person, I do think that that is sort of a trait of building an actual application, whether it's in Rails or not. And that is the audience of the code that you write for applications is one audience. It's your group or your team or your organization. And you don't generally show that code outside of that particular team or group or organization. This means that the art of developing applications is often the art of ugly one-off decisions and the art of not writing into abstractions and writing code that's a little messy. And that's actually good. I think that a lot of times we tend to stress out about writing perfect code, and I'm sure that a lot of the talks at this conference are about how to make your code absolutely perfect and wonderful and appease the programming gods, looking down upon you from the past. But we often forget that code that is terrible is often the code that actually helps real people, right? So, for example, Twitter is a web application that I love and hate at the same time, and they had lots of problems scaling because of Rails is sort of famous now, and from what I heard internally, their code was really terrible, but it actually was useful. Like, the reason that I hated the fact that Twitter went down all the time is because it was really, really useful, even though it sucked, right? And I've written a ton of subroutines in my career that are absolutely horrible, and I'm ashamed at the contents of their code, but they have worked really well, and they have served their users, and it's like made, things work for a very long time. And so I think that it's okay for applications to be a little bit messy. And there's sort of an art and a skill to writing code that's a little bit messy and not stressing out over writing the perfect code and just actually shipping something that someone will use to their own benefit. I have so many weekend projects that are still in production long after I thought that they would actually be in production. Yeah, this is mostly because you're the only users, and so you can know these details, and it's fine, and it helps you ship things quicker. Like, ultimately, applications are about shipping value as fast as possible rather than being perfect. And there's a certain kind of niceness that goes in there as well. The other cool thing about applications is that you can start at the top of the stack, and so I think that it's often a rich place for beginners to start programming and writing applications rather than these other things. And that's super cool because you get to go from this sort of top-down area. I am just old enough and I started young enough that I sort of learned bottom up. Like, I learned this, I did start off with BASIC, but you had to know assembly code to use computers in like the late 80s, early 90s, still, even to a large degree. And so I kind of learned from the like assembly and then higher level things. But today, if you're beginning, you're starting at the top of the stack. You're using a super high level language like Ruby or Python or what have you. And you don't necessarily need to know all of those lower details. And I think that's super cool for like accessibility reasons, but it also means you make certain kinds of trade-off in application development that you cannot when doing other kinds of development. So for example, you can use a garbage collector that was written in 1968, and that doesn't really matter until you get to a certain point where it becomes an actual problem. You can make sort of trade-offs for, I want this to be nicer and not worry so much about performance and stuff like that. The other thing about application development that oftentimes happens and is sort of different than in other kinds of development is that many people that do application development work in consultancies where you essentially are churning out apps over and over and over again. You work on something for 6 weeks or maybe 6 months, and then you get a new client and you're building a new application, and 6 weeks and 6 months, and then you get a new client and you're building a new application, and there's 6 weeks and 6 months. It just kind of goes on forever and ever and ever, and this sort of like Groundhog Day of CRUD apps, right? And all those things are useful and great, and some people really enjoy doing that kind of thing, but you can get this sort of assembly line feeling as well. This is the part where I admit that I'm terrible at building applications. And the reason why is because I am that person that over-obsesses about perfect code. I worry too much about building just the right abstraction. I will spend an extra couple days refactoring a whole bunch of things and not actually delivering an additional value, just like making my code climate score go down and doing all these kinds of things. And that's just because I'm the kind of person that loves abstraction and loves playing with abstractions, and that means that I'm a bad application developer. And there are so many people who are good application hackers who you may look at their code and go, oh, gross, but they'll actually ship the feature before you do, and it will be more useful than whatever else. I recently was rereading, there's a very famous sort of like flame war between Linus Torvalds and Andy Tannenbaum whenever Linus introduced Linux to the world. And in some ways, this kind of expresses this sort of like application versus library thing where Linus is like, it's just some code and I'm shipping it and whatever. And Tannenbaum said, monolithic kernels, that's terrible. Everyone's doing microkernels nowadays. That's the wrong kind of abstraction. Like, your code sucks. And they sort of fought back and forth. I always thought that was sort of interesting because, Linux now runs the world in many ways, and Minix is not really in existence, basically, or does not have any real-world impact, right? Whether or not that's because of Tannenbaum's over-obsession with perfection or not is totally, necessarily unrelated, but it's interesting. Another fun fact I looked at, one of the things that was mentioned in that thread was pretty soon by the end of the year, we're going to have computers that will be able to do 400 megaflops. And I went, looking at old things, this is like 1993 was when that email was written. So I was like, let's look at what my phone does now. And so I looked up like an iPhone 5S, and the number was 18,400 megaflops or something. So yeah, computers, super fast. It's really bizarre to think about, and again, in terms of how young our industry is, right? Like this phone is more powerful than most computers I've ever owned in my entire life, and that's really weird. I spent most of the day trying to pre-order an iPhone 6, so I got phones on the brain. All right, so that's applications. One-offs, it's okay to be ugly and actually possibly good to be ugly. Don't want to over-abstract. Then we have libraries. So I think working on libraries is where I personally found my stride as a developer, and it's what I really enjoy doing, and that's why I maintain far too many Ruby gems. So the level of abstraction is a little bit higher when you're writing a library because a library that's only used by one person is not that great of a library, right? Like sort of by definition, libraries have multiple sets of users. And if you're lucky, they will have a large number of users. And if you're unlucky, they will have a large number of users. And this is the good and bad thing about libraries, right? When you have other users, that means you have responsibilities to those other users. And that means that you have to interact with those other users. And that means you have to be on the receiving ends of mean tweets by those users and all sorts of other things like this. It also means there's tons of positivity and you get to work with brand new people, right? Because maybe you've only been working on the same team for very long, but you maintain a library and you get to interact with people all over the world. I've had this happen with my Ruby gems. I've been lucky enough to not have the same group of people on each one of them, and so I get to be on way too many teams, which is really great in some ways, but really bad in others, right? Because there's that whole law of networks where the complexity of the network goes up by n squared with the number of nodes, right? So 2 people communicating, there's 1 line. 3 people communicating, there's 3 lines. 4 people has 1, 2, 3, 4, 5, 6 lines and just keeps going up, right? So you get this communication overhead that can happen because it's no longer just one thing, it's many. And that can be awkward. Another interesting thing about libraries is eventually you want to add new features to them, which means that you have to not break old features, which means you have to start actually thinking about stability because it's not just your application where you're deploying master or whatever to the web, and I'm thinking of web applications when I say that. Obviously desktop applications, you sometimes have to support older things and whatever, but when you have a web app and you just deploy master all the time, you can break stuff and you're the only user and you're the only deployment, so it doesn't matter. The old ones didn't even exist right after you do deploy. But when you're a library, you have to start thinking about these kinds of issues. And you have to make sure that you're not going to break your old users, that when you work on old versions, you don't screw things up. And this can lead to a lot of stress that you wouldn't have if you were just building an application. So one of my favorite examples of this, I like to talk about my own failings in this instance. I maintain a gem for Ruby called Rescue, where it's a job queue, basically. So you put things on the job. It's called Rescue because it goes in Redis. So there's a job in the Redis queue. Some workers pop stuff off the queue. They do the work, pretty basic. It was originally written by GitHub, and now I'm in charge of it. And it has, you can never be fully sure, but it has about 30,000, 40,000 active users of people that use this. I have friends who work at Living Social where they use this to process credit card information and all that kind of stuff. So that's super neat, but that's also a lot of pressure. At first I was like, oh, cool, I get to work on this really popular, well-known project. And then I started going, oh man, I'm now really stressed because my friends work at Living Social and they use it for credit card processing. So if I introduce bugs and the credit cards don't get processed and they don't make money and my friends don't get their paychecks and oh no. And I managed to convince myself that that was okay and not a big deal for a while until the fateful day when I shipped a version of Rescue that was just completely straight up broken. I won't get into all of the details here, but basically what happened was my test framework was requiring a library that my actual the non-test environment was not requiring. So I applied a minor patch, everything looked good. I ran my tests, they were all green. I decided to cut a release to 30,000 people and got emails about half an hour later about like, did something change? Because I can't start up any of my workers. And they would start up the workers, it would try to load the library, and that would kill them, and it would instantly fall down and fall over. And I then had to admit my own failures and apologize and like add the one-line patch of require, you know, this line or whatever. And then everything was good and golden. But even when you try your best and you trust your things and you write tons of tests, this still happens, right? So this is an additional kind of stress that you don't have when you're working on applications. It's also great in a certain sense because that means that all these people know who you are, which can be good for your career and lead to things like standing up on stages in front of people. But it also can lead to those people all knowing your name when you're the one that broke them in production on a Sunday when they upgraded, you know, whatever. So it's always a double-edged sword with these kinds of things. And new features are fun to write, but now that you have multiple stakeholders, you have to actually have some sort of process by which you decide which features get in and which features don't get in. And you may, if you're not the maintainer of a library, but you hack on a library, you may want a feature, but the maintainers don't want the feature, and so you have to convince them or cajole them or bribe them or whatever to get your feature in. Which can take a lot of time and effort. And I never thought as a kid when I was programming that like arguing with people over the internet would be a core career skill. But it turns out that like figuring out how to not piss off the person who is maintaining that library you depend on when you like ask them for a new feature is like a really important skill to have. I learned that the hard way on both ends of such things. And then once you have your favorite feature in your favorite library and you're like working on all these things and it works, then you have to start dealing with like configuration, right? Because like some people want a feature, but some people won't want a feature. And it's not always possible to just not use the feature. Sometimes that feature is like one of the core things that you're doing, but it's reasonable to not actually use it. So now you have to figure out how to actually configure that feature, and you have to figure out like, do I use a file to configure it? Is this environment variables? And you start adding all this additional complexity that comes in because you're serving these multiple stakeholders. And so like, there's been endless problems with configuration in almost all of the projects and libraries that I have ever worked on. And then you have things where like, okay, so we found a security hole in a feature and we should really turn it off by default, but that's a breaking change. And so like, do I just like accept that I'm gonna break my users, but that's good because there's a security flaw? Or like, do I ship it with the default to off so that I don't break people's stuff and just beg them to upgrade even though I know they never will and they'll still like have this flaw in their thing? And that can be really annoying, and you know, and then people who don't know that context and history will come along and say, "You have insecure defaults. This project sucks," and you have to like deal with their harsh comments and arguments and whatever. Another interesting thing about working on libraries is that so it can be cool in like a pure open source sense when you're just building it because you have this love of the library, but when it gets complicated is once multiple companies start getting involved working on a particular library, because then money gets involved, and it's not just ego, which is enough like communications and complications problems, but then you have like people's salaries and like, we need this feature to ship this thing because this is like part of our business, and you can get into fights and like all this other stuff. You know, so I like worked on Ruby on Rails for a long time, and so in a certain sense, like DHH was my boss, but like not really. Like he didn't give me a dime ever, right? But I had to like listen to him, and I couldn't like do certain things I wanted to do because, you know, of reasons. But like I was never employed by 37 Signals, but it gets really weird and gray and awkward, right? Once you start having this kind of situation. And then there's also like process that gets involved, right? Because each company builds up its own internal process for doing all of these kinds of things. And so you have to come up with some way of convincing everyone to use some sort of shared system. This has happened to us with Mozilla when we're working on Rust, because Mozilla has their own internal tooling, but like almost everyone in the open source world is kind of standardizing on GitHub for better or for worse. And so there's been this awkward part of like making the Mozilla tooling work with GitHub instead of it being totally separate, and like, And this could be good and bad. Like a number of Mozilla developers have told me that they like miss Bugzilla, which I can't personally imagine because I hate Bugzilla. But like they're like, man, I really wish GitHub Issues is bad because Bugzilla could do this thing. And I'm like, GitHub Issues is good because it can't do that thing. And so there's this kind of friction that happens when you're forced to use tools that you don't want to or know how to use. And so this is like a cultural clash that comes into these things. And so then the last thing that's sort of a negative but also a positive about library development, before I start getting positive, because I feel like I've been super negative towards the beginning of this, is the like air quotes fame angle, which I sort of hinted at before. So like when you release software and you put your name on it, and then people start to know who you are, which is cool. Like my open source development has led me all over the world. I was like in Amsterdam last week at another conference speaking at that, right? And I never got to travel as a kid. We never had the money to do that. And so it's opened numerous amounts of doors for me and other people that do open source work. But it also means that there is like dedicated people in the world who like actively hate me and give me shit all the time. And like that really sucks. And like I never thought, just like I never thought that arguing would be a core competency, I never thought that like putting up with people saying mean things to you that are like deeply personal on a regular basis would be a core career competency. But apparently it is for me now. And that's what happens when you don't like work in one single company and you start trying to broaden your audience, right? So it's a great super thing. I've met tons of wonderful people that are more wonderful people than negative people, but like every negative person counts for like 10 positive people, right? I love and hate the Oatmeal, the comic, but he has this great comic about creating where he's like, for every like 100 comments I get about this one comic being wonderful, there's one negative comment will just completely ruin my day. I woke up this morning to a piece of writing that I've been working on for the last 2 months. It was on the top front page of Hacker News with 70 comments already, and I haven't even read it yet because I just don't want to because I know it's going to be full of people being mean. So that's positive and negative. But I will say that I love working on libraries, and while I've been sort of a little down on this, I think, so far, it's also really cool because it's where you get to exercise those powers of abstraction, right? And when you're working on other people with their code, your code does need to be cleaner, and therefore it is worthwhile to take the time to put in the right amounts of abstraction and to focus on the abstractions you're building and to like do the right things according to the right way, according to whoever blogged about that, the right way last week, and do all this kind of stuff because unlike in application development where abstraction is a liability, in libraries, abstraction is a strength because you need to have those new features, which means that making your code more extensible is actually useful. You need to be able to like work on older versions and cut new features and do all these other things and support stuff, and that's much easier when your code is nice and clean. And when you start getting into these complicated patterns of like social activity, it's much, much easier to do that whenever the code is not horrible. This is one of the reasons why I really like doing library development is because I get to like take advantage of all that time and effort and knowledge that I've put into writing clean code or like using design patterns or doing all those kinds of things. This is where all those hours of work actually pays off and is useful and positive and good. So libraries are super exciting. You'll also notice that this difference, last thing I want to say about the difference between applications and libraries before I move on to languages, is that you notice that a lot of these concerns are sort of secondary out of the fact that when you have an application, the only users are you, and when you have a library, there's like multiple sets of users or multiple sets of stakeholders. So the way I want to start off talking about working on languages itself to sort of move up, again, this like non-existent progression, because this is what I'm doing nowadays. I've been thinking a lot about working on languages. I did a little bit of work on Ruby before I stopped doing some Ruby stuff, and now working on Rust is my full-time job. So I'm sort of transitioning I'm handing maintainership of a lot of my gems over to other people. I'm not doing as much library development, and I'm working on languages. And what's cool and awesome and sort of the core thing about building a language as opposed to building a library or building an application is that you have 100% of the users by definition. So like when you write a library, hopefully it's popular and like say like half the people in the language use your library. But when you're writing the language itself, like every user is using the language. And so that's the core thing that all these other ones, things come out of. Not all of them, but a lot of them do. So One of the things I love about working on languages is that you get to return to sort of these low-level details. So when you're building an application, like I would never write a web application in assembly language, right? Because that would be absurd. Maybe for a weekend fun hack thing, but if I was like being paid to do some sort of development, I would not do that. But when you're working on a language, maybe assembly is a little too low level, but you get to return to like thinking about what pointers are and knowing low-level details, because most of the time you implement a language in a relatively low-level language. It's becoming more and more popular to self-host languages, so this is not always true, but like Ruby, for example, is implemented in C. And so that's a great strength and a great weakness, because like I enjoyed working on Ruby itself because I never got to write any low-level C code anymore, but it's really hard to find Rubyists who want to write C to work on Ruby, because the reason that they're writing Ruby is that they don't want to write C in the first place, right? So, and as somebody who maintained some Ruby projects that were actually written in C and just exposed a Ruby interface, it was very difficult to recruit people, because like the reason you use a language like Ruby is because you don't want to do that stuff. But when you're working on the language itself, you can get back to those low-level concepts, and you know that sort of thing is fun and exciting for me. Also, that I think that if languages are where like reading blog posts about clean code and experimenting with abstraction pays off, I think that programming language development is the area in which using computer science concepts pays the most off. And I have a really big love-hate relationship with my CS degree. I did drop out to do a startup, but I eventually went back and finished because I thought I was going to go get an English degree. That's a long story I won't get into. But the important part, I guess, is that I paid way too much money for this education, and so I would like to use it sometime. And so this is the area where I get to use it, right? So you need to know some level of CS theory to write a parser or write a lexer, or you know, even writing a compiler. Compilers are inherently about taking a tree and transforming it into some kind of output, right? And that's like bread and butter early CS kind of concepts. And so even if I hadn't learned them in my actual education, it's an opportunity to go read those papers again and like pick up that stuff and like get real deep into the theory, which is something that I really truly love. What's sort of related to these two things, this low-levelness and the CS concepts, is that language development is both easier and harder than working on these other things. Because I taught for so many years, I tend to speak to a lot of beginners, and there's a million code boot camps that are starting up now, and they're often looking for people to come talk, so I end up talking to beginners a lot. And one of the things I enjoy telling them is that, and sort of one of the major themes of this talk, is that these different niches are more and less interesting to different kinds of people. So we all have different strengths and weaknesses for whatever reason, and we all have different interests and things that bore us for different reasons. And so part of like enjoying your career as a programmer is finding the specific kind of thing that really gets you excited and working on that. So for example, I have friends who are operating systems developers because they think that building web apps is too hard. When you talk to them, they're like, an assembly language statement does one thing and it always does it. It's running right on the processor, so I know exactly what's going to happen. My code needs to only run on this one architecture or maybe even this one machine, so like I can make that exactly happen. The stuff that you do is you embed a programming language and a styling language, which has its own problems, into a markup language, and then you wrap that up and send it over a protocol which is running on top of another protocol, and it ends up on a machine somewhere else in some other part of the world that might not even be running the same version of the software, let alone the same operating system, let alone have the same like physical processor architecture, and you expect it to not only work, but to look the same as when you run it on your machine. And they're like, that is really freaking hard. I can't imagine how that's what you do every day. And like us in the web development world, we tend to think about operating systems as being really impossible and difficult and like low level and like too hard. And so whenever you hear people talk about a certain part of programming being hard, I think that it's important to remember that that is hard to them, and that's something that you may agree with or you may not agree with. I am a Haskell fanboy sometimes, although I haven't coded in a couple years, and the hardest part about learning what monads were for me was getting over that everyone told me monads were supposed to be hard. Like, once I actually read a paper that explained how they worked and I like worked through some examples, I was like, this is it? This is all the more this concept is? And that's not because I'm a super genius or anything, but it's because I was told by people over and over and over again that monads are super difficult and they're really impossible. Unless you know a bunch of obscure math, you're never going to be able to learn them, so don't worry about it. So I like started reading a category theory book, and I was like, this is really hard. If you've ever picked up a book on category theory, it was like, I read the first page, and I was like, this makes perfect sense, and this is pretty straightforward. Functions, map objects, and stuff. And I flipped the page, and I was like, okay, this is getting a little more complicated. And I flipped the third page, and I couldn't understand it at all. The difficulty level for me just went like, whoop. But I have a friend from college who's doing machine learning stuff, and like she reads like math papers like that and eats them up, and that's super easy for her. So we all have different things that we enjoy and different things that are useful. And so if you haven't done a certain kind of development, I would encourage you to at least try it out, because you just never know that might be the thing you're super into. It's funny that I work on a programming language now. I actually have a really weird fear of parsers. It's like a mental block where and parsers are one of the easier parts of a compiler, supposedly. They're not that straightforward, but parsers terrify me. I don't know why. I try to work on a parser, and it never works. So this means that every single programming language I work on is either a brainfuck or a Lisp or something where the parser is super trivial. Okay, so yes, working on a language is both easier and harder. Other thing, as I touched on before a little bit, you have lots of users. So by definition, you have all of them if you work on a popular programming language. If you use an unpopular programming language, then you have no users, which is its own kind of liberating, right? So you can do whatever you want with your little toy language. And what's funny is programming languages are sort of shifting. A lot of the languages that we use for development now were sort of invented in relative obscurity and sat there for a while, and people could do whatever they want with them. And then all of a sudden kind of exploded in popularity, and that meant that we had to deal with the warts that happened because of that, right? So I like to explain this in terms of Ruby. So Ruby was originally released in 1995, completely open to the public, but everything was in Japanese. So unless you knew Japanese and programming, you were not using Ruby for a very long time until 2001, 2002, 2000, somewhere around there. So it was 5 years of Ruby before you could even use it if you only spoke English. And then even after that, most people didn't use it until Rails. And by then, Ruby had been grown a bunch, and it has lots of warts, and they're awkward. And so we just sort of you learn Ruby, and you have to deal with these compatibility issues. And then also, as the person who makes Ruby, you kind of wake up one day and your baby, which has no users, now has a ton of users, and you have to deal with all that kind of stuff. My other favorite example of this is JavaScript, which if you ever talk to Brendan Eich about the history of JavaScript, he always looks a little sad whenever you criticize JavaScript, because JavaScript was written in 10 days. I don't know if you know that or not. Basically, they're we need to make Netscape a little bit better than the competitors. It's 10 days till the deadline. Brendan, can you implement a scripting language so that people can customize their web pages with little silly stuff? And he was like, yeah, sure. And you as that employee, you never think what that guy should have said is, hey, Brendan, in 15 years, your programming language is going to be used by everyone to build everything. So don't fuck it up, because everyone's going to hate you for it, right? So I always think of that. I always think of Brendan Eich as a tragic figure in many different senses, but specifically with the development of JavaScript, because he had no idea that his toy little hack. I mean, they named it JavaScript just to not make fun of, but to imply that it was kind of like Java, even though that's not true at all, right? So it's effectively 100% marketing-driven little tiny feature we're just going to toss in here for a moment that is now I watched multiple talks this year where people talked about JavaScript replacing assembly code as the concept of all new programming languages should now compile to JavaScript, and we will just make computers run that stuff now. And that's something that you never think about whenever you're doing these kinds of things, right? So yeah, you go from nothing to everything. One of the things I really respect about JavaScript in general and its future development is how much they take backwards compatibility so seriously. And I know some friends that work on it, and it's a super big, intense process to make that work. But they are facing the backwards compatibility issues with a kind of responsibility that I've never seen out of any other group of people. It's really fantastic. You can write JavaScript code and it will work forever, but it's also kind of terrifying that you can write JavaScript and it will work forever. So yeah, that's cool. Another interesting thing about programming languages and language development is that I think that taste and choice affects programming languages significantly more than applications and libraries. And what I mean by taste and choice is that if you're building a library, let's say you're building a web development library so for someone to build web applications in the programming language you're in, if somebody doesn't like your library because they say I hate the way you named your functions and the interface is kind of gross and you should have this other kind of abstraction, you can pretty much tell them, if you don't like it, go implement a different web development library in this programming language, and that's cool. You can just use that one. And so while taste does matter when developing libraries, it's not like the final say of the word. Like, you can develop alternatives relatively easily. But when you're developing a programming language, there are certain decisions that you have to make that do not have an objective component by which you can say that this is truly better, which means that some other people will disagree with the decision that you're making, and you kind of have to make it knowing that they're going to have to live with your decision forever. So like, when we were developing Rust, one of the recent hugest arguments, we actually have an RFC process to like introduce a change. So you like propose a change, and then we argued about a bunch, and then we do it or not. And one of the most participated in discussions, to make it sound so much nicer than it was, about Rust syntax was to use square brackets instead of angle brackets for generic parameters. This resulted in multiple hundreds of comments about preferences one way or the other. And as a programming language designer, there is no objective like way to make that decision. It's like the most trivial of decisions possibly. They're both even brackets. It's not like I like this syntax one way or the other. It's about whether it's super tiny or like bigger, right? The most simple thing. But your users are gonna have to put up with it. And so you kind of have to be okay with like just saying, I appreciate the feedback, but I'm going with this decision, because it's almost impossible to get true consensus from everyone who uses a programming language. There are going to be some people that hate you for your decisions no matter what you do, and you just kind of have to deal with it. As I mentioned before, working on a programming language is often in a different language than the one you're programming in, although it's becoming less and less common nowadays, so the Ruby and C example being different. Rust is written in Rust, so I don't have to deal with that this time, but otherwise. The last two things that are super awesome about programming language development, and by awesome I mean one is awesome and one is not awesome. The not awesome one first. It is much harder to get paid. I am incredibly lucky that Mozilla has money to pay people to work on a programming language, and so I happen to get paid to work on a programming language. But it is very, very difficult to find the resources if you're not. This is one of the benefits of being on the Microsoft stack, right? There's endless money to pay people to work on Microsoft languages. But if you want to work on like an open source language, it's very, very difficult to find sponsorship to get you to actually do that work. There are very, very few number of people that get to do that, and so that sucks. Which often means you either take a pay cut or you do it on nights and weekends and like that kind of thing. I'm always surprised. Until relatively recently, there was no one that was paid to work on Ruby professionally. And like I was thinking, like all these Rails apps that are built, and like the core fundamental thing that runs them all is literally a hobby project. Like we are good at building these ridiculously tall castles that are just poke them a little bit and they fall over. Okay, and the thing that is super awesome about language development, and one of the things I love about it most, is that you get to be the first person to do whatever thing it is. So, there's not a JSON library in that language until someone comes along and does it. If you show up before the JSON library is, that gets to be you. And I think that this is like the best way to determine if working on a programming language is good for you or not. If you say, that sounds exciting, you should work on a programming language. If that sounds terrifying, you should not work on a programming language. But the cool thing is so when I think about all those people who I like admire and respect in previous programming language environments that I've worked on, like, oh, this person maintained all these early things. This person did all this great stuff early on in the history of a programming language. That gets to be you if you're working on a new programming language. Do you want to be the person that writes the first ever web framework? Totally can be you. We did not have regular expressions in Rust until someone in the community came along and said, I've actually been thinking about implementing regular expressions, so let's do this. And they wrote it, and they're awesome. Both they are awesome and their software is awesome. But like they get to be forever remembered as like Burnt Sushi is the person who wrote our regular expression implementation. And that's super cool. And something that it really, really appeals to me a lot is getting involved super early and being the first person to do it. Okay, so that's sort of all I have to say specifically about these things, so I'm going to wrap it up. So yes, I think that these three different kinds of categorizations of projects are significantly different and useful to talk about and think about. I think that we're all in this together in a certain way, so I definitely don't want to imply that any one of these things is better than the other or not. And I think that we do a lot of harm to each other by talking too much trash about various things. I'm more guilty of that than most people, which is why I can say it. One of the things that I've learned is useful is that no one knows what we're doing at all. So like, if you're like, why does this language work that way? There's probably some good reason or there isn't a reason, and like somebody just doesn't know. And so, the people that you think of as your programming heroes that like, oh, that's the person that built that first thing in the regular expression implementation. Why is it 30% slower on this regular expression? Like, because he didn't build it the right way or whatever, right? Like, we're all sort of figuring this out together as a discipline. And so I think that thinking more about programming and the way that we talk about programming and the divisions amongst programmers is super useful. I think that there's going to be more of a split between the theoretical computer science degree and the vocational bootcamp degree, quote unquote, in the future. And that's something that's sort of changing right now and I think is really useful. So yeah, find your niche, enjoy what you're doing, and let's all have fun with programming. Thanks. I think that's it. I don't know if questions are even appropriate, but if you want to ask me questions, you can. I don't know. Whatever. Cool. I will see you all later. Thanks.